In the late 1930s, the leadership of the U.S. Army Air Corps came up with an ambitious idea. Their goal was to create a cutting-edge interceptor with unprecedented flight performance. In the fall of 1939, the Air Corps issued a strict new set of requirements and announced a design competition. This drew immediate interest from aircraft manufacturers. Officially, the document was known as Circular Proposal R-40C, issued on November 27, 1939. It demanded a fighter whose top speed, climb rate, maneuverability, armament, and pilot visibility would all surpass anything already in service, while still remaining cheap to build and easy to maintain. Among the specific benchmarks laid out in the document was a demand for aircraft capable of climbing to 20,000 feet in under 6 minutes, a genuinely aggressive target for the era. Crucially, the Army made a point of stating it was open to unconventional configurations, effectively giving designers a green light to get creative. The Army brass couldn't have predicted that it would result in some of the most unusual piston engine fighters in American aviation history. In fact, these incredible aircraft effectively became the swan song of radical American propeller-driven fighter design. The extremely strict requirements for the new airplane essentially forced designers to push the envelope with highly unconventional engineering solutions. Altogether, 13 different companies took part in the competition. Interestingly, 9 of them submitted designs featuring a pusher configuration. This meant the propeller was mounted at the rear of the aircraft. This layout looked incredibly appealing. Why? Because with a pusher setup, the propeller would not waste energy blowing turbulent slipstream over the fuselage, which creates excess drag. Plus, it allowed engineers to concentrate all the heavy armament right in the nose section. This not only made maintenance easier, but it also meant designers didn't have to deal with complex synchronizer gear to fire through the propeller arc. The pusher layout itself was not brand new. It had been experimented with as far back as 1915. But it only really gained traction in American design circles during the 1930s, largely thanks to Bell Aircraft. That company had already explored the concept with its troubled Aerocuda heavy fighter, and would go on to pitch its own pusher design, the Model 16, for this very same competition. So it is no surprise that all 3 finalists in the competition went with this unconventional layout. Even so, each company interpreted the pusher concept quite differently. Vultee chose the twin boom arrangement described here. Curtiss went with a canard layout for its ascender, placing horizontal control surfaces ahead of the wing instead of behind it, and Northrop pushed furthest of all with a stubby, nearly tailless flying wing design for its black bullet. But, as is so often the case in aviation, there is no such thing as a perfect design. Even during detailed development and early testing, serious flaws inherent to the pusher configuration began to rear their heads. At the very beginning, however, things looked fantastic. In the spring of 1940, an Air Corps review board finally selected the winners. First place went to Vultee Aircraft, whose design racked up an impressive 817.9 points out of a possible 1,000 under the Army's scoring system. Second went to the Curtiss-Wright Corporation, and Northrop Aircraft took a close third. The Air Corps decided to greenlight the construction of all 3 aircraft. By that summer, the companies were tasked with finalizing their detailed engineering designs. Originally, the plan was to power all of these aircraft with a massive 24-cylinder liquid-cooled Pratt & Whitney engine. This was the promising X-1800. It was projected to produce 2,300 horsepower and was still in active development at the time. However, the project ran into severe developmental issues, and work on the power plant was ultimately canceled. This was a shared misfortune. All 3 finalists in the competition, Vultee, Curtiss, and Northrop, had designed their aircraft around this very same engine, so its cancellation sent every one of them scrambling for alternative engines, which severely delayed the schedule. This competition was only Vultee's second serious attempt at fighter design. Their first, the Model 48 Vanguard, had failed to attract any real interest from the Army, and ended up seeing most of its combat service overseas in China. Still, as soon as Vultee received the competition requirements, their engineers got right to work at the company's main plant in Downey, California. They actually had a bit of a head start. Even before the contest began, the company was already developing the Model 78 fighter, originally conceived as a pusher-propeller design intended for the export market. It was powered by a 12-cylinder V1710 engine. the very same power plant that would go on to power the P-38 Lightning, the P-40 Warhawk, and early versions of the P-51 Mustang. Based on its projected performance, this aircraft was already very close to the Army's new requirements. So the designers simply used it as a baseline and adapted it to fit the Pratt & Whitney engine. They then pitched it to the Air Corps under a new company designation. This was the Model 84. It was this updated design that ultimately took first place in the competition. The Air Corps issued Vultee a contract for wind tunnel models and technical data on June 22, 1940. After further refinement, which included extensive wind tunnel testing of scale models, Vultee presented the final design of their fighter to the Air Corps. On paper, Vultee's early performance goals were staggering. The company promised a top speed of 510 miles per hour, a range of about 500 miles, and a service ceiling of 37,000 feet, all from an airframe projected to weigh a mere 8,500 pounds at gross weight. Reviewing the projected performance specifications, Army leadership was absolutely blown away. After all, the new aircraft was expected to reach a top speed of nearly 500 miles per hour. So in early 1941, the company officially received an order to build and test the first prototype, assigned the serial number 41-1210. Its official military designation would be the XP-54. Vultee employees themselves came up with an unofficial nickname for their creation, the Swoose Goose. It was a playful nod to a popular novelty song of the era about a bird named Alexander, who was said to be half swan and half goose, a hybrid described in the song simply as a swooze. Coincidentally, that very same nickname was already attached to a famous B-17 bomber, one that still survives today as the oldest surviving flying fortress in existence. The sudden cancellation of the original X-1800A3G engine put all the finalists in a tough spot. It left each company searching for an alternative. For their promising XP-54, the engineers at Vultee decided to go with the Lycoming XH-2479-1 engine. This power plant was still in the testing and development phase. The original contract had promised delivery of the finished prototype by July of 1942, but the engine swap alone pushed that timeline back by more than half a year. However, it could produce 2,300 horsepower on takeoff. It could also steadily maintain around 2,000 horsepower at altitudes over 31,000 feet. Throughout the design process, the fighter underwent numerous modifications. In the fall of 1940, for example, the Army Air Corps suddenly issued new requirements. They wanted to significantly improve the high-altitude performance of the aircraft. They also needed heavy armor added to the cockpit, including armored glass in the windshield and steel plating around the pilot's seat. Because of this, designers had to completely rework the nose section. This was necessary to accommodate a pressurized cockpit and add 2 massive turbochargers to the engine. These major additions did not come without a penalty. As a result, the gross weight of the XP-54 skyrocketed. The initial design called for an airplane weighing around 11,460 pounds. But after all the changes, the maximum takeoff weight swelled to nearly 18,300 pounds. By the time the aircraft was finished, its empty weight alone had reached 15,262 pounds, with an absolute maximum takeoff weight of 19,337 pounds. To deliver the incredible performance Vultee promised for their new fighter, engineers had to incorporate absolutely every cutting-edge aerodynamic innovation available at the time. The aircraft design also boasted a whole range of unique technical features. The designers opted for a twin, boom, mid-wing configuration. It featured an incredibly clean and sleek central fuselage. By this time, a twin-boom layout was not exactly a wild and exotic concept anymore. A similar setup could be seen on the Dutch Fokker G1 and Fokker D-23 fighters. It was also used on the famous American Lockheed P-38 Lightning. Unlike the P-38, though, which used its twin booms to house 2 separate engines, the XP-54's booms carried no power plants at all. They existed purely to support the tail, since the aircraft's sole engine sat behind the pilot in the central fuselage. The wing took on an unusual cranked W shape. The leading edge of the inboard section was swept back 24 degrees. Meanwhile, the outer wing panels actually featured a forward sweep. Tucked inside that center wing section was a unique cooling system. It was specially designed by NACA experts and refined through the same extensive wind tunnel testing program that shaped the rest of the airframe. All of its components were housed entirely internally and flush with the skin. This meant nothing protruded into the slipstream to create parasitic drag. Fresh air was drawn through intakes on the leading edge of the wing. It was then routed through special ducts straight to the coolant and oil radiators. Interestingly, the landing flaps pulled double duty. Aside from their primary job during landing, they also acted as cooling flaps. This helped to control the airflow through the radiators. The central fuselage itself was slender with a circular cross-section. It was constructed from magnesium alloys and relied heavily on welded construction. All told, the finished aircraft stretched 54 feet 8 3/4 inches from nose to tail, with a wingspan of 53 feet 10 inches, a height of 14 feet 6 inches, and a total wing area of 455.5 square feet. The armament and nose landing gear were housed in the nose compartment. Right behind it sat the pressurized cockpit. Beneath the floorboards, they cleverly routed the aircraft's vital systems, including hydraulics and wiring. Between the aft cockpit bulkhead and the firewall, they installed the main fuel and oil tanks. Additional fuel was distributed into wing tanks. This brought the total fuel capacity to nearly 230 gallons, enough on paper to support the roughly 500-mile range Vultee had originally promised the Army. In the aft section of the fuselage sat the true heart of the fighter. This was the powerful Lycoming XH-2479 engine, one of the most ambitious liquid-cooled aero engines under development in the United States at the time, though it would ultimately never progress beyond a handful of experimental test units. It drove a massive 4-bladed Curtiss variable pitch propeller. This propeller had an impressive 13.5-foot diameter. This 4-bladed setup was actually a compromise. The original design called for contra-rotating propellers to better handle the engine's torque, but the switch away from the Pratt & Whitney power plant forced engineers to abandon that more complex arrangement. Another interesting detail involved the tail booms. Tail booms typically run strictly parallel on this type of aircraft. However, the designers took a different approach here. The booms canted smoothly inward toward the empennage. The distance between them at the wing root was 18.2 feet. But by the time they reached the tail section, the gap had narrowed to 15.8 feet. Engineers settled on this canted arrangement partly to keep the horizontal stabilizer well clear of the pusher propeller's turbulent wash. Pusher prop designs had one serious, even fatal flaw. If a pilot had to bail out in an emergency, there was a massive risk of going right into the blades of that flying meat grinder. To fix this, engineers tried to kill two birds with one stone. They wanted to guarantee a safe mid-air bailout. They also wanted to make it easy for the pilot to climb up into the high cockpit from the ground without having to hunt down a ladder. The solution was pretty incredible for its time. They built a special hatch into the belly of the fuselage. Guide rails were mounted right on the inside of it. Thanks to an electric motor, the pilot seat could be lowered down just like an elevator. In an emergency, the hatch would pop open instantly. The seat would slide down the rails, and the pilot would drop well clear of the deadly propeller. Of course, all this complex hardware added a lot of excess weight to the airframe. This was especially true since the entire system had to be fully pressurized. Still, it represented one of the earliest serious attempts anywhere to solve the pusher aircraft bailout problem, arriving years before true ejection seats would become standard equipment in American fighters. The armament on this fighter deserves a special mention too. Two heavy 37mm cannons packing 50 rounds each were hard-mounted in the nose. They sat right alongside a pair of 50 caliber machine guns with 500 rounds per gun. But the craziest part was that the entire nose section of the aircraft was not fixed in place. It was mounted on a special pivoting hinge connected to the nose gear strut. This allowed the whole nose and its guns to elevate 3 degrees or depress 6 degrees. To keep rounds on target with a setup like that, the pilot used a specialized compensating gun sight, one capable of computing both angle and range automatically. In period paperwork, these cannons appear under a confusing tangle of designations, sometimes listed as the T9 and elsewhere as the T12 and T13, reflecting just how experimental this weapon fit still was. Construction on this ambitious fighter progressed quickly. By early 1943, the aircraft was ready for testing. It made its first flight on January 15, 1943, which lasted 31 minutes, with test pilot Frank Davis at the controls, taking off from Muroc Dry Lake in California, the same stretch of desert known today as Edwards Air Force Base. The flight went fairly smoothly, aside from a malfunction with the Curtiss propeller, which was later swapped out for a Hamilton Standard unit. Test pilots highly praised the maneuverability and handling of the new design. However, one massive problem soon reared its head. Top speed maxed out at just 401 miles per hour. This was almost 100 miles per hour slower than what the designers expected on paper. Unfortunately, the weight penalty from all those complex onboard systems really took its toll. This was compounded by a lack of engine power that just could not push such a heavy airframe. On the plus side, recorded figures showed an initial climb rate of 2,300 feet per minute, with the aircraft able to reach 32,100 feet in just under 28 minutes and a service ceiling of 37,000 feet. Before long, another serious flaw made itself known. This was a direct result of that unusual pusher-prop layout. Engineers had to ensure plenty of ground clearance for the rear-mounted propeller blades. Because of this design constraint, pilots couldn't pitch up sharply without risking a catastrophic prop strike. As a result, just to get airborne, this fighter needed an incredibly long ground roll. It was almost the same distance required by heavy bombers of the era, demanding around 2,950 feet of runway. The next major blow to the project was the sudden decision to completely pull the plug on developing the intended Lycoming engine. Naturally, the design team tried to save the program and pitched an alternative. They suggested swapping in another high-power engine, specifically the Allison V3420, a massive coupled engine that was also being considered around the same time for other experimental heavy fighters then in development. But by that point, the Army Air Forces were already rapidly losing interest in the new fighter. Mass production was no longer even on the table. Despite these setbacks, they decided to push forward with flight testing anyway. By March 11, 1943, after just 10 flights, it was already clear performance was falling well short of the guaranteed figures. To make matters worse, engineers found traces of metal in the engine oil, forcing the aircraft back to Vultee's Downey plant for a complete engine change. Testing then resumed with 86 additional flights out of Ontario, California. By then, the aircraft had already racked up 63 hours and 10 minutes of flight time. It was handed over to Wright Field in Ohio, the Army Air Force's main center for flight testing and evaluation for further military assessment. Once there, the Lycoming engine failed yet again, this time damaging the turbo supercharger and grounding the aircraft for good. The story didn't completely end there, though. On May 24, 1944, the second prototype took to the skies for the very first time. Interestingly, the Army Air Forces had actually placed the order for it 2 years prior, on March 17, 1942. For decades afterward, historians actually had the wrong serial number for this second prototype. It was long assumed to be 41-1211, when in fact it carried the serial 42-108994. The confusion likely traced back to a simple painting error on the airframe itself. Visually, this second airframe differed from the first prototype, which had flown in a full camouflage paint scheme throughout its career. The second aircraft, by contrast, featured an unpainted bare metal finish. Additionally, instead of 2 turbochargers, it was equipped with a single General Electric unit, a change that simplified the aircraft's systems compared to the twin turbocharger arrangement on the first prototype. Its flying career, however, turned out to be even shorter. The fighter logged just 2 full flights. Afterward, it was sent to Norton Army Airfield in California. There, it was stripped for parts. Shortly after, the prototype's nose section was shipped to Eglin Field in Florida, the service's primary armament proving ground for further weapons testing. Ultimately, persistent engine troubles and, crucially, a severe shortage of spare parts took their toll. In the summer of 1944, the ambitious XP-54 program was finally canceled. Both airframes were eventually scrapped entirely, a common fate for canceled prototypes during the war. Today, nothing physical remains of either XP-54, only photographs and paperwork. The experiment cost American taxpayers a hefty sum for the era, $1.5 million split across design, construction, and testing of both experimental airframes. As it turned out, none of the 3 R-40C finalists ever reached production. Curtis's second-place entry, the tailless XP-55 Ascender, was plagued by dangerous stall characteristics. One of its 3 prototypes crashed during a test dive in November 1943, though that pilot managed to bail out safely. A second was lost in a fatal crash during an air show at Wright Field in May 1945. Northrop's third-place Black Bullet fared no better. Its tailless, near-flying wing layout proved chronically underpowered and unstable, and after its own troubled test program, the Army Air Forces canceled that project too, in the summer of 1944, the very same season the XP-54 met its end. As fate would have it, the XP-54 went down in history as the last aircraft built by Vultee. In March 1943, the company had merged with Consolidated Aircraft. They eventually became legendary under their new name, Convair. In the years that followed, that same company would go on to produce far more successful and influential aircraft, from the enormous B-36 Peacemaker bomber to a whole family of Cold War-era jet fighters and bombers, a legacy the strange, ill-fated Swoose Goose never got the chance to share in. Looking back, the XP-54 stands as a perfect example of just how far American aviation engineers were willing to go when handed a truly open-ended challenge. Nearly every system on the aircraft, from its belly-mounted escape elevator to its pivoting gun nose, represented a genuine attempt to solve a real problem in an entirely new way. That so many of these solutions never panned out does not diminish the ambition behind them. If anything, it is precisely why the pusher fighters of the R-40C competition, the Swoose Goose chief among them, are remembered today as the last great gasp of radical, propeller-driven fighter design in American aviation history.